In chapter 10.2, you'll notice a lot of the exact same stuff that we've been doing. You might think to yourself, man, did we do this already? And the answer is yeah. So this will be a little bit of a lighter day. Here's the table that's in your notes. Mine didn't copy very well, so I wrote them out by hand. It will be helpful to find totals for your columns and rows. So here's the first class, and I went and found columns. You can either copy mine or find them yourself, either way. So add up your columns. I have totals down here on the bottom. Add up your rows. Here are the totals over here. And then down here in the very corner, you have the total number of people on the boat. There's going to be 2,201. There's that one extra. If you notice, that's Jack. There was supposed to be 2,200 people on the boat. Right at the end, Jack wins the poker game, gets the ticket, hops on the boat. So that's why there's 2,201 and not 2,200. Anyways, a lot of these, out of all, we'll just dive right into it. You're going to look for your prepositional phrases. Those will help you out a bunch. So out of all the people on the Titanic, as soon as you read that, that will help you know what your denominator is. Of all the people on the Titanic, that's 2,201. What percent died? Well, once you have these totals, it's nice. You can just look at number 1,490. And just to save time, I'll let you punch out that division and figure out the percentage. What percent of crew members? Very similar to our conditional probability. And if you use that tactic, it does work. But of crew members, we already know that we have 885. And then the ones who died would be here, the 673. Once again, you can punch that out and calculate that. Let's see. Pause it and just try the rest. The examples really are just finding information out of the table. Find the percentage, look at this, of passengers in first class. So of passengers in first class, that's 325. Who survived would be 203. It looks like your odds are pretty good there, 203 out of 325. Find the percentage of passengers who survived who were in first class. So your survivors here are at 711, and then your first classers are 203. So if you notice, you could paint two slightly different pictures. If you wanted to maybe skew the statistics a little bit, you could play with the words a little bit. People do this. I don't have a great example right off the top of my head, but you can see that if you're in first class, the odds you survive are really good. I mean, we're 203 out of 325. Looks like 62% chance, roughly a 62% chance. But if you change it ever so slightly, you could say, well, of those who survived, only 203 were first class people. It's 203 divided by 711. So a 28.6% chance. So you could say, well, being in first class wasn't that great. Only, of those people who survived, only 28.6 were in first class. Well, that's a way that you can kind of lie with statistics a little bit, just to play with it. So if you're ever reading a survey, or if you're reading some research, you want to be really careful, especially what you hear on TV. Let's see, would it be worse to be in third class or in the crew? You can think of this as, find the probability you die or the probability you live. Either way would be fine. So if we're talking about the third class, there's a total of 706. So I'm a glass half full kind of guy, so we'll find the probability you live, which would be 178. If you're in the crew, there's 885, and the probability you live is 212. So here, 178 divided by 706 looks like you have a 25% chance of living. 212 divided by 885 looks like a slightly 24% chance, so it's slightly better to be in third class than in the crew. All right, just to be careful down here, the percent of people, which would be bigger, the percent of people who are 6 feet tall. So that, once again, the percent of people who are 6 feet tall, your prepositional phrases will help you out. So people who are 6 feet tall, there's millions of them. I tried to Google it and figure it out. It took me down all kinds of different sources of information, and it really wasn't worth looking up. So, yeah, millions who play in the NBA. The number of people in the NBA, 400 people maybe. So you're getting a very small, it's probably less than that. Shows how much I know about the NBA, but you're getting a very small number. But the other way around, the percent of people who play in the NBA, that would be 400 or so, who are 6 feet tall. I bet almost all of them. I can't think of all that many guys who are under 6 feet. So let's say 390, I don't know, something like that. Very high number. Once you narrow it down to NBA players, very high number are going to be 6 feet tall. All right, on page 7, you want to know what? This is the same type of stuff. It's not terribly tough. If you have questions, email me, but we're just going to skip this for time. Last thing we want to fill out is this table. I'm going to spend a little bit of time going through the math behind it, and then I'll show you, of course, a nice little shortcut to make it go quickly. So, in the table below, Mr. Rosema pulled students and recorded the results below. Fill in the individual spaces, and here's the key: if the two events are independent. And that's what makes it tough. Because you might be thinking to yourself, well, can't you just slap in any number you want as long as the numbers add up to 65 and add up to 120 and add up to 130 and add up to 75? Why do we care? Well, there's only one way to fill these in so that your events will be independent. So the two events here are gender, which one you are, and if you like pre-calc or not. So if the two events are independent, here's what we know. The probability of one event and the probability of the second event will be equal to the probability that both events happen. Okay? In independent events, you can multiply probabilities and get the probability that both happen. Okay, so right here, this right here is the intersection of two events. Okay? Event number 1 is that a student is male. Event number 2 is that pre-calc is their favorite. And I want to find the probability that both of those events happen. The probability that you get a male and the probability that pre-calc is their favorite. So what we're going to do is we're going to calculate those individually, and then we're going to multiply to see how it works. So if we're going to multiply pre-calc, who is their favorite, that's going to be event 1. That's going to be 120 out of 195. The second one, male, would be 65 out of 195. Okay? So the probability, since it's independent, I can multiply their probability. So the probability that someone is going to land in this little square right here is the multiplication of probabilities. So I'm going to go on here and go 120 divided by, what is it, 195? Did I do that right? Yep. Times 65 divided by 195. And I've got this for a probability, and I'll math frac it for you. And you get an 8/39 chance, that someone will do both of these, be both a male and have pre-calc for their favorite. Or another way to say it is that 8/39 of the people will fall into that category. So if I go times 195, that means that there's going to be 40 students who are male and have pre-calc. So I found their intersection by multiplying. That gave me the probability. I took the probability and multiplied here to get that number. So now we can, once you have one number, the rest kind of autofills. So 40, I needed 25 in order to add it up to 65. 40 and 80 has to add up to 120, and then 80 and 50 has to add up to 130, and it's always a good idea to make sure your rows and columns all add up. All right, so let's take a quick look at what I just did, guys. I found the probability of event 1. Okay, this is the 120 out of 195. Found the probability of event 2, 65 out of 195. When I was done, I took that number and I multiplied by 195. Okay, so 195, if you notice, here's a divide by 195 and here's a multiply, these cancel. So if you want a shortcut to find anyone, all you have to do is go 65 times 120 divided by 195. So if I want to fill in this blank, just kind of find the rows and the columns that match, go 65 times 120 divided by the total. So see if you can use that quick trick to fill out this table. You can either go through all the math like I did, or you can just go 132 times 70, 132 times 70, and then divide by 154, should give you 60. As soon as you have 60, the rest autofills for a 72. This would be a 10 and a 12, and make sure everything adds up and you got it. Like I said, there's lots of ways to fill out the table, but there's only one way to fill it out so that the two events are independent.